Okay, it was kind of lame to have to end the last video in its middle, let's say, but we have this restriction that we can go over 20 minutes. So we're back here, and in this last bit, we're going to actually instantiate the blocks. Of course, we will need a two-dimensional array because we're dealing with both columns and rows. And I'm also going to define a variable here that's going to be the number of rows that I want to have for this block of wooden planks. So rows. And my two-dimensional loop will go as follows. For int x starts out as 0 and goes up to the number of rows. At each iteration it's summed up by 1. And we'll do the same for y. Instead, it goes up to the number of columns, and at each iteration we're going to sum it by 1. And for each of these items that we're placing, we have to pick randomly one of these blocks. So to do that, we just have to grab a random index, and we already know how to grab a random integer. So we can just apply this knowledge to grabbing a random game object out of this set of blocks. So first of all, let's get a random index. So int random index. This will be equals to random.range between 0 and blocks.length. Since the last integer is excluded, we can just pass blocks length. We don't have to do blocks length -1, afraid that we may end up grabbing an index that doesn't exist. Because if the length of this array is 3, we're going to randomize a value between 0 and 2, so 0, 1, or 2. So we can make sure that we're not going to grab an index that doesn't exist. And the actual game object, the random geo, is blocks of index random index. There we go. So now we have to instantiate a copy of this item. We can just place it in the world because it doesn't exist in the world. It only exists in our prefabs folder. So to instantiate it, I'm going to assign it to a local variable. Instantiate it, if I can type, instantiated geo will be instantiate random geo. And this function returns an object, and I'm trying to assign it to a game object, so I need to typecast it to a game object. Alright, so this is good. Why I didn't assign any position in the instantiate function? Because I surely can assign positions. Because I already have a reference to the instantiated geo, so I can deal with its position, scale, and all of that, just so we don't get a line that is too long. So first of all, we need to assign its position. Instantiated geo dot transform, which is its transform component, dot position. We're gonna assign no position for it. And now let's see how we are actually computing this position. We know that actually we want to grab this top left corner here. And this top left corner has x coordinate minus screen divided by 2, and has y coordinate screen height divided by 2. But I have a loop, so I have to keep in mind that I need to displace this initial position depending on my current elements of the loop. So on the x-axis, I want to displace the block width times my current column, which is y, times the scale multiplier. So make sure we are displacing them at the right rate so that the end block ends up just at the rightmost part of our window, of our game window, okay? For the screen height, we actually need to subtract whatever our block height is, so we will need that information as well. times x times, and that's it. We don't have a scale multiplier for the y component. So let's put that into Unity. So we need to give this man a new vector 3 position. The x, as said, will be minus screen width divided by 2 plus, and here comes a big bunch, block width times the scale multiplier, and don't forget times y, because we need to take account for the current column we're actually computing. For the y, this is a nice trick. You can put a comma here, hit enter, and continue in the next line so you don't get something that goes too long in here. Alright, for the y, it's going to be screen height divided by 2 minus block height, which we don't have. So we need to define this block height. And the block height will be pretty much the same as this guy here. Just Ctrl C, Ctrl V here. Just copy and paste. And instead of grabbing the x component of the size, we're going to be grabbing the y component. Of course, we could easily store this into a variable. We store the sprite renderer of the index 0 into a variable and then access its bounds and then its size and making it look better. But it doesn't really matter because we'll only be calling this once in the start function, so that's not a problem. And we need to multiply this by x. And in the z parameter, I'm going to pass in 0 because this is two-dimensional. And we're not done yet. We need to take into consideration that we are possibly changing the scale of this element. And this is given by this scale multiplier. So we need to change the scale of this element. So the instantiated geo.transform.local scale will also receive a new vector 3. And for x, we want to change its width. So it's going to be whatever the value it is right now, instantiated geo.transform.local scale, and this long.x, so whatever value it is right now, but times the scale multiplier, because as said, we need to change its scale so it fills our entire screen. And in the y and z axis, it's going to remain whatever it is. So instantiated geo.transform.local scale.y, and in the z we just have to pass in 1 because it doesn't really matter, right? And I guess this is it. So let's just make sure you call this function inside the start function. So we are creating our blocks, create blocks group, and hopefully this will work just okay in Unity. So let's go back to Unity. Let's check for errors. There's none. So I'm gonna get rid of this wood plank 1, delete it, and let's actually create a new game object just so it contains this Woodblock creator script. So game object create empty. I'm going to assign this Woodblock creator script because it has values that needs to be filled in the inspector, so blocks and rows. And for blocks, I'm going to assign each of my prefabs, so wood plank 1, wood plank 2, wood plank 3. So now that these guys are there, I just need to assign a number of rows. So let's start by putting three rows here. Hit enter or hit play, and it works. It's just great, right? It's just mathematics. So as you can see, we have that they are perfectly aligned with our view. And man, I didn't expect this to work right away, but it did. So let's try to play our game. And it looks like we get a very nice working game right to this point. Of course, there's one thing we need to start working on, which is making it better looking. We have nice sprites, but we don't have any sorts of particles, we don't have sound, we don't have animations. So we need to start working on that. And also, if I change my aspect ratio here, this is ugly, I know, but just to explain something, of course, my wood planks, they're totally dynamic, so they're gonna fill my entire screen, but my platform can't go any further. So this is something we need to correct. Okay, this is a problem, and we need to do this to allow that our game is playable in any sorts of screen resolutions. Alright, so this is going to be done in the next video, and this is it for this one.